Salutation to everyone. Today our group will do a presentation on computer architecture project, which is programmer calculator. The group member are me, Ansem Singai Anak John Kasira Tegong, Nur Atikah Azira, Muhammad Nabil Arbi, Chua Yilin, Sean Maximilian, and Caroline Engda. In this project, we will be designing and developing a programmer calculator by using assembly language. The two functions in this programmer calculator are number system conversions and performing a Boolean operation. We use an online assembly language compiler for this project as shown in this slide. There are three main objectives in this project. Number one, to understand the number system used in computer architecture. Number two, to familiarize with assembly language. And number three, to enhance the presentation skills and teamwork among the group members.
Hi, as you can see, this calculator has display screen that show both the input and output. This allows programmer to work with number in their preferred base. To input number, the calculator usually has dedicated key for digit 0 to 9, along with additional key for the letter A to F in hexadecimal mode. In addition, the programmer calculator can convert number between different bases. This feature is particularly useful to represent binary decimal and hexadecimal number. You can easily convert a decimal number to binary or vice versa with just a few clicks. The programmer calculator also supports logical operators such as AND or XOR and NOT. These operations are vital in programming, especially when working with Boolean value. I hope this explanation has shed some light on the design of a programmer calculator.
Hi, and this is the tutorial on how to use this calculator designed in code by our group. When we run the program, the user will get this interface, which they will ask to input the function that they want to choose. First, we will see the conversion of a number system, so I will enter 1. Then, the program will ask the user to select the initial base that we want. For this example, I will type 1 for decimal number. Then, it will ask for result base for the conversion that we want. For this example, I will type 2 for hexadecimal. After that, the program will ask the user to enter any decimal number. This is also applied to other number systems based on what the initial base is. The result of the conversion will show up with a follow-up message for the program to continue or not. For this tutorial, I will continue with another function, which is Boolean operation. After the user enter 1 to continue, the user will come back to the menu. Then, we will proceed by entering 2 for the Boolean operation. Then, the user will ask to choose an operation. For this example, I will use OR operation. After that, the program will ask to enter 2 digits, which consists of 0 and 1 only. I will enter 0 and 1. By right, the answer should be 1. And the answer is correct. And to exit the program, we just need to enter 0 and the farewell message will show up. That is all for this tutorial. Thank you.
So I'll be explaining for conversion. When the user runs the program, the user met with a welcome message and the program prompts the user to pick a function between conversion and bool operation. But on this slide, I'll be focusing on conversion. If the user selects one, which is conversion, the program will prompt the user for 2 things. One for the base of the number before conversion, and the other one is the base of the product. A calculation algorithm to convert a decimal to hexadecimal is implemented. In this case, the number is divided and the remainder is kept to be repeated until the quotient becomes 0. Then the program rewrites the remainder backward, producing the hexadecimal. In this program, the conversion of numbers to ASCII characters is used, and looping it to change it back to an integer to confirm its value. Next, a similar process is used here for the decimal to binary conversion. It is a similar looping system that repeatedly divides the input number by 2 and then stores the remainder, which is either 0 or 1 in a buffer line.
To convert a hexadecimal value to a decimal value, the user first inputs a hexadecimal number into the program, and the program first checks from the right whether each character is a digit or a letter. And whenever they scan a digit, first before that the program will clear the EAX register using the XOR operation. So no matter what, it will be 0. So it will be cleared. And after that, from the right, it checks for every digit or character, and if it's a digit, it will add the value into the EAX register, and if it's a character, it will first convert the character into a digit using the ASCII, and then it will add into the EAX register, and then later on the program will output just the EAX register. Similarly to the hexadecimal to the decimal conversion, the hexadecimal to binary conversion will first convert and store the value into a register. Then afterwards, you use that value to divide it by 2, and for each remainder, it will be stored in a buffer, and later the buffer will be printed as its binary value. So basically, what it's doing in a sense is changing it to decimal first, then change the decimal back to binary. For binary to decimal, the program first saves the input. Let's say, for example, 1010, and from the right, from 0, the program checks whether it's a 1 or a 0. So first it counts 0, and if it's not 1, then it doesn't do anything. It goes to the next iteration and checks if it's a 1. So in this case, 1010. The second one is 1, and it's the second iteration, so it's 2 to the power of 1. First, it's 2 to the power of 0. So first, it multiplies by 1 by 2 to the power of 1 and saves it inside a register. And it goes on for each iteration, and if it's a 1, if it checks the digit is a 1, it will multiply it by 2 to the power of which iteration it is, starting from iteration 0. So then it will print out the decimal value that is stored.
For the Boolean operation, the code first prompts the user to select which operation they would like to perform. In this case, an operation is chosen. The program is then prompt the user to enter 2 values. As shown in the figure beside, when the user enter 1, 1, which is 1 and 1, the output is 1. And when the user enter 1, 0, which is 1 and 0, the output is 0. To perform the output, the program first checks the input and compare it with the value 1. If the value 1 is not detected, the program jumps to line 280 to perform AND0 function to print the result as 0. Meaning to say that if 0 is detected, the output straight away print the result as 0, because only 1 and 1 will result as 1. Similar concept to OR operation, only 0 or 0 will result as 0. As shown in the figure beside, the input 1, 0 result the output as 1. This is say so because when the program checks there is value 1 entered, the program performs jump if equal command to print the result as 1. For the second input 0 or 0 as shown in the figure, the output is 0 since they are not equals to 1 respectively. The program will not jump and instead print the output as 0.
Now, we'll be talking about Boolean operations XOR, or more commonly known as exclusive OR operation. Similarly to the OR operation, the XOR operation or exclusive OR operation will output 1 if 0, 1 or 1, 0 is entered. It slightly differs from OR operation, however. When 1, 1 is entered, the output will be 0. When compared to the OR operation, when 1, 1 is entered, the output will be 1. These are according to the XOR truth tables. The way we change it is so that a function is called when the first byte is checked and equal to 1. Then a second check on the second byte will be done. If it's 0, the program will jump to a function, 12 to output 1 since it will be 1, 0. Otherwise, it will jump to output 0 and then 1, 1. This is the way we change it. as the input would be 1, 1. Let's say if the initial byte is 0. The program does not jump initially and will check the second byte. The program then compares it to 1 and jumps to output 1 if 1 is found at the second byte, meaning the input is 0, 1, and not jump and output 0 if 1 was not found, meaning the user inputted 0, 0. Next, we'll be looking at the Boolean operations for the NOT operation. According to the NOT truth table, when 1 is entered, 0 should be the output, and when 0 is entered, 1 should be the output. So, for the NOT operation, in this calculator, the program checks for the number 1 in the byte, and if it exists, then it will just jump to output 0. Otherwise, you will only continue the program and just output 1, as the input could only be 0.
This project demonstrates the importance of effective communication and collaboration in achieving successful teamwork. By thoroughly planning and designing before starting the coding process, the team was able to structure the program effectively. The emphasis on testing and debugging proved crucial in identifying and rectifying errors promptly. Throughout the project, the team gained a deeper understanding of assembly language and honed their problem-solving skills. So, this experience provides valuable lessons in teamwork, planning, testing, and technical proficiency. That's all from us. Thank you.